Gamma-proteobacteria. This is probably the most familiar group of bacteria to you that there is. And again, just like most of the gram-negative bacteria you think of are proteobacteria, most of those in turn are gamma-proteobacteria. And so all the enterics are in this group. E. coli, half of the organisms you used in general micro are in this group. Things like Proteus and Salmonella, Shigella, Serratia, all those creatures. We're going to talk also about Buchnera. This is an insect symbiont. The Vibrios are in this group. Pseudomonas and all of its relatives are in this group. My favorite organism, Veggiatoa, is in here. I'll show you some pictures of that. And Chromatium, the purple sulfur bacteria, are in this group. These are the organisms that cause the pastelly purple you might see at the bottom of your Winogradsky column. So again, there's lots of heterotrophs, lots of pathogens, and lots of autotrophs as well. And so the enterics are in this group. And here's faithful E. coli, probably the best studied organism in the world. Let's talk about Buchnera. Wait a minute, that's not a bacterium. That's an aphid. I want to look at myself. Buchnera is what drives this animal's life cycle. These organisms are sapsuckers, right? Can you imagine, and I hope you don't have, or I hope you don't know, hopefully you have to imagine, living on a diet of flat 7-Up. That's basically what these things eat, right? Sugar, water, maybe a little bit of minerals, that's it. How well would you do with that? Breakfast, lunch, dinner, midnight snack. Nothing but stale 7-Up. You wouldn't survive long, right? You get energy, but you don't get any of the vitamins and essential amino acids you need to survive. Well, why do they call amino acids essential amino acids? They call them that because you have to get them in your diet, right? You're biochemically unable to produce them yourselves. Those essential amino acids are the same for all animals. So these animals can't make lysine either. There's about 10 of them, I think, that animals can't make. And they don't get it in their diet. What about things like riboflavin? What about thiamine? Go down the alphabet of vitamins that you need to get in your diet. These animals need that too. Where do they get it? From bacterial symbionts. And so they have an organ in their abdomen called the bacterome that's full of Buchnera acidicola. And the animal drinks up that sugar water, sends it to Buchnera, and Buchnera makes all this stuff for the animal in return. If you treat a plant with ampicillin, water it with ampicillin every day, aphids will not grow on it. Because the aphids get that ampicillin. The ampicillin kills the Buchnera and the insects die. It's absolutely essential for their survival. The thiotrichs are also in this group. This thing is Veggiatoa alba. Any of you guys ever been to a sulfur spring? There's some in the mountains west of here. No? Any of you been to an estuary or salt marsh and seen white filaments in the water? Yeah. That's these creatures right here. These things are sulfur oxidizers. They oxidize primarily hydrogen sulfide and thiosulfate and related compounds. The intermediate of that is elemental sulfur, which they store as granules intracellularly. That's what these things all are. If you take those filaments out, remove them from their source of sulfide, they will continue to grow because they can use these sulfur granules as an energy source. This continue the oxidation to sulfate. And so ultimately they'll turn colorless. They'll start out white and they'll turn colorless over time. These were taken from I took this picture, it's a very famous spring in southern Indiana, an old resort called French Lick. Very popular in the 20s and 30s. You were supposed to bathe in the waters and it made you feel great and it was very healthy and this sort of thing. It used to be that bathing in springs was considered a very helpful thing to do. A very famous resort there. You're supposed to drink the water and it has all kinds of health benefits. It smells really bad. It's rich in sulfide and that kind of stuff. Certainly not good for you. They closed down. They won't let you near the springs anymore. Not because of the sulfide, but because the water is full of lithium. That's why it makes you feel better. It's got nothing to do with sulfur or actual health. Also, the pseudomonads are in this group. There are actually two kinds of pseudomonads. The fluorescent pseudomonads, these are things like Pseudomonas aeruginosa. And then also the nitrogen-fixing pseudomonads. These things usually have azoto or azo in front of their name, like Azotobacter or Azomonas. And these things are free-living nitrogen fixers. Lastly are the purple sulfur bacteria. And so like Veggiatoa, these things oxidize sulfide to sulfur and store them as intracellular sulfur granules. They look like a bag of marbles. And when you put them on the slide, they immediately start to consume that sulfur, and over time they'll turn colorless. But they're also purple photosynthesizers. So they need that elemental sulfur as a reductant, the sulfide or elemental sulfur as a reductant to fix carbon. But what they're using for energy is light. And so this combination of the white color from the sulfur granules and the purple color from photopigments means they're kind of a pastel-y purple, and they're strict anaerobes. If you get those purple blotches in your Winogradsky column, you definitely want to pull some out when we dismantle the column and have a look. Chromobacterium is a really cool organism.